not be feasible or appropriate when the answer is no or can't tell to one or both screening questions. So it is only when both of them are yes, it follows a question. Follow the procedure. But there is one more thing here that we should remember, that the MMAT tool cannot be used for here. The MMAT tool can be used to appraise the quality of empirical studies and or primary studies, observations or experiments. It cannot be used for non-empirical papers such as review or theoretical papers. So if it is a purely theoretical paper or is that some mathematical paper or a paper like that, it may not be able to review such papers, right? So based on the screening question, you will go further. So that is the first thing. Respond to the two screening questions. Responding no or can't tell to one or both questions may indicate that the paper is not an empirical study and it cannot be appraised by the MMAT tool. For each included study, choose the appropriate category of studies to appraise. Now once you have said yes to both these questions, then comes the next type of study. Is it a qualitative study? Is it a randomized controlled trial? Is it a quantitative non-randomized study? Or is it a mixed method study? So we will have to categorize your study accordingly. So this is, remember, it is critical appraisal tool. So for each study, this paper should be attached. Is it a quantitative approach appropriate to answer the research question? Yes, no, can't tell. Are the quantitative data collection methods adequate to address the research question? Are the findings adequately derived from the data? Is the interpretation of the result sufficiently substantiated by data? And is there coherence between qualitative data sources collection, analysis and interpretation? Those things has to be mentioned here. And if yes, if no, whatever the comments has to be given. Right? Similarly, depending on the type of study that you are evaluating or appraising, you go to that column and appraise that study. So that's what I said. There are only 5 questions for randomized controlled trial in this MMAT schedule. But actually RCTs have a very tough or a very rigorous critical appraisal.
And that would be only in case of experimental study.
Yes. RCTs are experimental.
Only experimental.
So then, if it is a descriptive study, is the sampling strategy has been adopted? Is it representative of the target population? All these things. So once this is the tool that is applied, and each of these questions need to be addressed. And for each included study, the appropriate category has to be used. So then it says that it is discouraged to calculate an overall score from the ratings of each criteria. Instead, it is advised to provide a more detailed presentation of the ratings of each criterion and be better informed. This may lead to perform a sensitivity analysis to consider the quality of studies by contrasting their results. So excluding methodological quality, low methodological quality is usually discouraged. Here it says, using a mixed method tool, if the studies have a low methodological quality, you still appraise it and keep it ready. So they are not excluded because it fulfills the inclusion criteria, but it is of low methodological quality, and therefore they are given low scores, but definitely they need to be evaluated at least. And this is how that it is done, and it's a very simple tool. I found this a very simple tool. There are more complicated tools in critical appraisal.
But this is a 2018 version. That's a 2020 as well.
So that is Prisma. Prisma is a reporting framework. This is an appraisal framework. There is a difference. entire review rather than be addressed as a separate stage. So in the review itself, you write it down. And the recommendation is given in the planning stage. Consider is there any existing conceptual or theoretical framework for the and the analysis stage. Consider any synthesis method which encourages theoretical development such as content analysis, thematic analysis, or discussion in consideration. So this is a very good. I think you can will leave these slides with you. If you are planning to do an SR, and the next steps are quite easy. Setting up a review question, preparing, writing up a clear review question, and the review objective should be very clear. Then third one is to see what is it? Epistemology. This is again related to qualitative studies, epistemology and paradigm. And then next one is the SRM protocol. Limitations. The SRM protocol. Yeah, preparation of the protocol, how to do it, and they have given examples of the step-by-step methodology. They have given references of studies which you can try, and how they have made recommendations how to improve that, create the inclusion exclusion criteria, and how to write up a detailed protocol. And then come the methodological techniques and protocol, standard protocols, whether grade literature needs to be included, is to be included, how should we go about doing it, and searching open source data. So I think these are very important points for management research. Similarly, selection of the studies, the recommendations, and quality assessment of the studies, how to do quality assessment, which methods you should follow, and comes next, mapping of the studies, how to do a systematic analysis. This is all qualitative in nature, so I didn't understand it, so I'm just leaving it to you. Whoever does qualitative analysis, they should be able to.
Normally the qualitative analysis of HR.
Then the synthesis methods is relatively easy for me to understand. Quantitative methods are similar to the usual synthesis methods only. And you do a meta-analysis also in case you have the data. But usually the management studies are mixed methods. Right? So there is the problem. I have never tried. Maybe when one of you approach me, then probably I will start learning it. So these are the you should go through this. These are very interesting recommendations made. So that's all I think I have for this.
So we go to the same you are the statistical part which you want to do.
Yes, you want to continue?
Yeah, we can continue at times.
Are you bored or you want to make it
No,
ready?
I really enjoying all this.
said that we can use that value and convert that value into a standard normal variate because we want to use the tables, and once the standard normal variate is calculated, oh, I think we did this. So we have to just say whether it is yes or no. If that is so, just the standard normal variate is compared with the 95% confidence limit, 95% Z value, and that is 1.96, right? And if it is less than, since minus 2.5 is less than minus 1.96, it is in the rejection region, and therefore we say that the null hypothesis is rejected, right? So this is and we also said that it can we can also generate the confidence intervals, and looking at the confidence interval also we can say whether the significance has been achieved or not, whether there is a statistical significance or not, whether null hypothesis is rejected or accepted or not. If it falls in if the value of as proposed by the null hypothesis falls within the confidence interval, then it is not significant. And if it goes beyond the confidence interval, it is significant. And graphically, if you want to look at the probabilities, we have looked at this also, and we can calculate the probabilities also. So then coming to this, I think this example was also done. This example was also done in which one is to reject or accept the null hypothesis, and we said that since Z is greater than 1.28, we have rejected the null hypothesis, and we have said that there isn't sufficient evidence to say that the base for medical base is less than or equal to 500, right? Or if you want to get a p-value solution for this, what to do is that you have to look at the probability. So the question is, what is the probability that the mean is greater than 490, because x bar was found to be 490 in the experiment. So we convert 490 into the Z value or the standard normal variate, and then that Z value is coming out to be 8.0. Now probability of Z greater than 8.0 is equivalent to saying that probability of 1 minus probability that Z is less than or equal to 8.0. Here, see here. Yeah, this one. So probability of Z greater than 8.0 is equal to 1 minus probability that Z is less than 8.0. What is the probability of Z less than 8.0? That is 0.99. Right? With this probability, if you calculate, then
This is like 90% level of confidence.
no,
Yes, because the alpha value is 0.10. Because the alpha value is
Alpha value is 0.10.
10.
Acha, yes.
That's what the confidence.
Even at 0.05 it is less. It is still significant at 5%.
Yeah, 5% also it will be.
5% also it is significant. At 10% also it is significant. We have also seen this example where we talk about the average cost of hotels in Bombay, and we have rejected the null hypothesis. And we have also, I think we have done all this. We looked at this. We were doing the paired test, right?
No, but now they don't use this critical value in most.
No.
They use p-value.
P-value.
All
Statistical analysis. And what steps or what requirements you should have to arrive at it or decide any analysis. So this is a very can also, now till now we have been looking at means. Now suppose there are proportions, and that is where your question was coming. So you are looking at proportions, right? So we should not apply e-test when you have proportions or categorical variables. For categorical variables or binary variables, there are other tests that are applied, and they are the ones that we will learn now.
Z-test we can apply.
Z-test, yes, sir, I'm coming to that. So the first one
You
is
know, the
the
rest of the questions you have to apply U equal to NB and standard deviation is equal to under root A.
here it is here. So you have a test of proportions. What is a proportion? Proportion is nothing but it's kind of a probability in which you have the number of successes or number of events in the numerator and the total number of events in the denominator.
Percentage.
No, so you are taking here. This is what I would like to do. So you are writing x by n because it's a sample size. If the sample size can be n minus 1.
Why? It is a proportion. Well, it's not a, it is a proportion.
But minus 1 in some cases.
I've seen something. That's something I have seen.
This is proportion. In proportion, how will it be n minus 1?
Because it's a sample. It's not from the population.
So what? Proportion means you will
I
not
forgot
do.
where this.
Standard deviation.
I have not seen.
Standard deviation.
Yes, there will be capital N, so population from over capital N, and then you have a sample size, and maybe in that case,
Proportions are not defined. No, I'll come to
I
that.
will tell you later.
We will come to that later. Proportion is number of events divided by the total number of events, right? And then if both n and what is it is not pi but it is p, right? Take it as
So,
p. This is p, not pi.
it's a p into 1 minus.
The np and
In other words, PQ.
no, np and nq. If np and nq are less than 5, p can be approximated by a normal distribution. So that is what I said. When np and nq are less than 5, or at least 5, then you can approximate it. At least 5 is less than or equal to 5, right? Then you can approximate it by a normal distribution with mean, this p, and variance square root of pq by n, right? So this is a case when a binomial is getting converted into a binomial situation is getting converted into a normal situation when the sample size is very large. And hypothesis test for such cases is the sampling distribution of p is normally distributed, and so therefore z will be calculated as p minus pi. What is pi? Pi is the population proportion, p is the sample proportion. Okay, and then you calculate the population sample proportion, and the population proportion is already known. Then only this happens, and then we calculate z and then compare z by the technique that we have saw. Now, if you have to, instead of proportion, you are looking at the actual numbers in the numerator, that is the x's that we are looking at. Then also x also follows a normal distribution. X also follows a normal distribution with mean np and variance npq. So this is a case of a binomial. And when for large sample sizes, x is a binomial variable with a mean np and variance npq, right? So when n is large, x follows a normal distribution.
That means you are saying that suppose if a coin is tossed 1,000 times, coin is tossed 1,000 times, the probability of getting 4, at least 4,
Probability of getting
at least 4 is, let us take it as, let's say that 1 by 5 or something. So this is a binomial.
this is a binomial and it is tossed
So
1,000
we can
times.
use it.
Yes, you can use it.
We can use it in this
You
case.
can use it here when n
So let us go to the back. Let's go. Why you have written that n is when your sample is greater than 5? What is the purpose of taking that 5? The hypothesis testing of x. If your x is greater than 5, what is that 5 denotes?
N minus x is greater than 5.
And if we say x is greater than 10 also, then we can say, if you say x is greater than 10, then it will come in the case of binomial. Because you are saying that more than 10, you start applying the binomial. Yeah, so less than greater than 5 means greater than 5 and n minus x is greater than 5. You have written.
X is greater than 5 and n minus x is greater than 5. That means n is very large. Right? Suppose n is 7. Suppose n is 7 and x is 5.
So if n is 1,000, if n is 1,000,
Definitely then it is. That's what if n is 1,000, definitely this is the case. When n is 1,000, binomial tends to normal.
will it not lead to a Poisson in that case?
Why Poisson? Poisson doesn't come into the picture.
But you are taking as a proportion.
Yes.
Why don't you apply the Poisson also in the
Poisson
proportion?
is for counts, sir. Please remember Poisson has a different purpose. Poisson is to look at the distribution of counts,
Not percentage.
frequencies. It is not for anything else. This is a binary situation. Should I record or so binary, you have here
Continuous distribution that is now.
continuous नहीं है, it's not continuous.
Then it's something like this.
It is not a continuous discrete distribution. It is a discrete distribution. Counts है, I'm talking about counts. And if you look at Poisson's law, e to the power of minus lambda,
Then what is the
lambda.
condition that why you are applying that x is greater than 5?
Now why that 5 has come, I don't remember. It could be 10 also, but if x is 5 and n is
If you take that x is less than 5, then I will accept it. Then x is less than 5, that is coming under the binomial.
No. This is not a case of binomial. This is a case of normal distribution. You are not
No, it is a normal
if it is
distribution.
x is less than
No,
5.
and it is a normal distribution so where you are applying an say the binomial because the mu is converted as an NP and your variance is converted as an NPQ. So only in the binomial only we will use an NPQ and we will use an NP. So in that case it becomes an say that
If x is less than 5, right? And you have a large sample size. So here you have to use the Boolean algebra. X should be less than 5 also. Then n minus x should be less than 5. Then only the binomial equation comes. That means n minus x should be, n should be 10
why it is
or
a 5? Why it is a 5? Should be less than 10 or change.
I don't remember why I put 5.
Standardizing
No, here no. You are standardizing only because assuming that x follows a normal.
yeah.
Then only it is standardized. See,
When
if
you're
n is large,
writing x is greater than 5, when question rises that it maybe you are presenting the standardization form. It's not like this.
Just one information from our PC.
And this interrupt from me. Following faculty are supposed to go to conference room with a meeting. The new faculty. Dr. Namrata Jain, Dr. Priyanka Arora, Mr. Vivek, Mr. Devji, Ms. Observed.
Is it conference hall or the real 220? Conference hall.
Let's lean for Mr. Padma.
Go to the ground floor.
Is the speed
Go to the ground floor. Outside you go to the conference hall.
doctors will be having all the new faculty.
Because this is a old slide that I made, right? So we go back and assume that x follows a normal distribution and this can be done. Here is an example which will make it clear that the dentist claims that he treats 8% of his patients from caries. To test this claim, a random sample of 50 were surveyed.
If 50 again after sample size already greater than 30 rupees.
50 were surveyed. So 50 and test at the alpha 0.05 significance level and test this claim. What is the claim? That it treats 8% of his patients from caries. Right. So then check first. So as we did before, NP, we calculate NP. So we said NP is equal to 4. What is P here? P is 0.08, right? Probability. And N is 50. So NP becomes 4. And NPQ becomes, NQ becomes 46. So NP and NQ are defined. Now once we do that, then the hypothesis, null hypothesis is that the probability is 0.08. Because now we are testing the proportion. And we are trying to say in the other one that it is not finite, it is not equal to 0.08, right? So once we do that, we calculate this by using the Z technique because N is large here. So P follows a, when N is large, the proportion follows a normal distribution with mean P and variance PQ by N, right? What is P? P is the population proportion, which has already mentioned here as 0.08. We are testing that. So P minus 0. What is 0.3 here? What is 0.3?
But actually,
15 by 15.
Maybe say that
Yes.
N into 1
15 by 50. Because if you did a sample of 50 and 15 responses were received, that means what is P here? P is 15 by 50, that is 0.3. Observed P is 0.3. Of the proportion that we are testing is 0.08. Right? 0.3 minus 0.08 divided by PQ by N, square root of PQ by N. If you do that, the Z value comes out to be 18.33. Just by looking at the Z value, you can say it is simple.
sample size is 550.
Yeah, and it's just
N is a
Actually, 500. These
over the chain.
are all very old slides of mine. So, sorry.
So then that case will not come 18.3.
Calculate करना होगा.
That's the equation.
0.3 minus 0.08 is 0.22.
Point 0.0016.
Z.
No. 0.0016 divided by 50. It is 0.00032.
P value. Z value. No, it won't be that small. It should be more than 1.96.
39.28.
Oh, larger.
It's not a 8.3. It's ज़्यादा ही होगा ना चीज़.
So anyway, that is.
That will be fun. That's calculation part is there.
So we say that that is greater than 0, that is greater than 1.96 critical value, and we can reject that. If not, then we can use a p-value technique also. You can use the p-value technique and look at the probability. Probability that y-value is greater than or less than or what. Okay. Then this is another example I give. I don't know whether you want to do it. Suppose a survey claims that more than 60% of the graduate student population of the government system was male. Believing the female population to be larger than they exist, you conduct a sample survey and found that your sample population of 320 grads consisted of 181 males. That means your observed proportion was 0.566, right? But the expected proportion is 0.6. Now we want to see, are your findings significant enough to suggest a population ratio less than or equal to 60%? Or if you want to see that, then if you do a hypothesis testing using the Z test that we last time we did,
So by the way, using that particular formula shows just one
it's
show.
the same, like it will be.
Because we can't use the.
This I asked my junior to prepare and he got it from somewhere.
Actually, mean also you are using basically the same.
Same formula. That's
It is
it.
x bar minus mu
Yes.
upon
Same thing, same thing.
sigma upon 100.
Normally we use mu upon and then say that the mean.
We don't he's used some of the formula. I asked him to make a few slides for me, na? So I taken that slide from him. Most of these are my slides, but this one is his slide. And I liked the way he wrote all this, so I put this. So first identify the hypothesis. Now here your hypothesis says that it should be greater than 60%, suppose. It is more than, what is your hypothesis? Here you are saying, believing that the female population to be larger than they suggest, they will conduct a
The proportion is given as a 56.6.
proportion is 56.6, and so the null hypothesis says that
That is a
alternate
56.6
hypothesis.
is the same population questions.
Yes, male
Yes.
male population. And your alternate hypothesis, if it says that probably proportion of females is 60% or more, then you take that as the alternate hypothesis, and the opposite of that will be the null hypothesis, and your proportion is 0.566. So you put that into this formula here below to get the Z value as minus 1.256. Now the probability of seeing minus 1.2566, what is that probability? That probability comes out to be,
Can we put the, suppose with the minus 1.256, we don't have the value for it. Can we put the say the mod over there at the top?
what do you say then?
Mod. Modular. P minus P cap minus P mod under root, then you can see.
Because the probability is the same.
Because it is a normal distribution.
Yeah, here you can see.
But in our case, we have to shade on the, what is say that, this side, left hand side. But you shade it on the right hand side.
Because it is a one-sided test.
Minus 1.
It is a one-sided test. It is not an equivalent test. So that is why it has to go on this side.
Then but even if it's in the side, minus means you should come always to shade on this side.
Rejection doesn't happen.
Not on the right side.
Rejection doesn't happen except if we control it.
Nice, sir.
Rejection return
Minus 1.25, you have to cross like this and then you have to do it. He is, the person who is done for her, ultimate is not
Correct here.
Should be closer to the
3000 plus
This
0.
side, it should be this side. There is a mistake here.
तो rejection return होना चला गया.
Irrespective, we are getting the pole. That is a positive or negative. At the time of the shading, you want to shade on the right hand side, left hand side.
Yes. So what he's trying to say here is that yeah, the shading has to be on the left hand side, and at 0.05, the z value is minus 1.96 if we are looking at equivalent test. But since this is a one-tailed test, you will have to look at z 0.05 only, and at 0.05 the z value is 1.65, right? Because it's a one-tailed test, it is not a two-tailed test. So z value is 1.65, and he says that what is he saying? There is sufficient evidence to support the hypothesis that the population of late graduate students constitutes less than 60% of the total population of the graduates. Yeah, so if you are taking that, so that means if that is a shaded region, then 1.65 should lie somewhere there, right?
That arrow is pointing at that place.
Value.
That is
Calculated value.
He has not shaded that. Moreover, that should not be there at that particular place. It should be very near to
This is something wrong.
That's not a tree, which I was not confused with that particular tree.
Ignore this. Ignore this question. Example.
This is for two sides.
This is for two proportions.
Yes.
So we were looking at one proportion. This is for two proportions, and this is also a z test only when n is large. When n is large, right? So this is a formula.
That means I can make a question like this. Suppose wheat eaters in Punjab is the probability of wheat eaters in Punjab is around 20%, and the same is in Gujarat is 10%, and the number of populations in Punjab is 500. We have taken the sample. Over here we have taken 300 as a sample. In that case, we can.
And if you want to test whether the proportion is the
We can use it.
no, she means comorbidity. She means comorbidity.
both samples are
She's right. Technically, she's right. Let us assume for the time being that all that is clear. This is a no. In both groups there are comorbid. They are balanced.
We cannot compare a group of youngsters along with a group
That
of
that you can do in the univariate,
Ah.
but when you do multivariate, that age factor will come in, right? So in a univariate case, they will be very significant. Then you realize these are old people and these are young, right? So now you got your answer, na? How to test whether Covaxin is effective or Covishield is effective. You have Covaxin, they have Covishield, right? How many fall sick in this group? How many fall sick in this group? P1, P2. P1 minus P2.
That's the test of proportions.
That's the test that we just had learned. No, that gives you whether the proportion of individuals who fall sick in the two groups is same or different. So, right? Then we will not look into their other things at all. This is all that we can answer. These are all univariate. We'll do multivariate but tomorrow maybe when somebody can choose it multivariate. So chi-square test is generally done for categorical variables. It is used both as a parametric test and as a non-parametric. So if somebody asks you whether chi-square is a parametric or not, it is both a parametric, right? So as a parametric I am telling you now, as a non-parametric we will again come, right? As a parametric test, how it is used? It is tested to look for normality. Here is the assumption. Chi-square test as a parametric test, it is tested to check for the standard deviation, testing for the standard deviation, whether it follows a hypothesized variance or not. Given the sample of a large size, you will test whether the sample standard deviation on the population variance also, then only it is a parametric test. So when if that is used this way, then this is a formula that is applied, and you can use a chi-square to test this. You can do a chi-square test to test this claim that this S square is equal to sigma square. S square is the sample variance and sigma square is the population variance. Here it is used as a parametric test. And again this boy is going to skip. I don't know whether to skip this. And otherwise it is a non-parametric. When we learn about it more in the non-parametric, so otherwise it is a non-parametric test. So how is it a non-parametric test? It is it's a very commonly used test to study the association between two groups, two categorical variables, and it also is used to look at the distribution of the data, whether it fits into any distribution, goodness of fit. So it is used for two purposes, for testing the goodness of fit and for studying the associations. Remember that it has to be drawn randomly from a population, not necessarily a normal, right? Because it is non-parametric. And then the cells should not be less than 5. If they are less than 5, then you do a correction factor. Yeah. And the sample size has to be sufficiently large, but you can also do it on small samples. It is a very robust test, and it has the only thing is that the categories should be independent and mutually exclusive. They should not be overlapping, right? And if this is what the chi-square value looks like, you have the observed frequency and the expected frequency, and you will see now later in my table what observed and expected means. And then these observed frequencies are actually frequency counts. You make a 2x2 table and you count the frequencies, and then this is a formula for calculating chi-square. So here is an example. Now here, if you look at this table, there is a hypothesis that cholesterol levels in heart disease is not associated. Somebody says, no, there is no, because even literature says, sometimes it says cholesterol is useful, sometimes literature says cholesterol is not useful. So it keeps changing. Recently it came up that cholesterol levels have nothing to do with heart disease. But we still test our cholesterol and we keep our LDL numbers very small. Right? So heart disease is not associated with cholesterol. HDL is good. LDL is
Sometimes they would say that 3 or 5 is fine with the heart thyroid categories. 8 is also fine. It's just that they give you some limits, so you have to keep that limit else to take the medicines.
Yes. So all that is very it keeps varying, and our hypothesis or our gut feeling is that heart disease is associated with high cholesterol. So that we keep it in the alternate hypothesis. And null hypothesis says there is no association. So if that is the situation, then you have 40 patients, you have selected 40 patients, out of which 23 had high cholesterol there and 17 had low cholesterol, right? Out of which 22 had heart disease and 18 did not have heart disease. So we have the marginal frequencies 23 and 17 and 22 and 18. These are the marginal frequencies. Okay, and then to calculate expected frequencies, this is the formula. Click on it. How do you get the expected frequencies? So these are the observed frequencies. Now to get the expected frequencies, you have to multiply the marginal frequencies and divide it by the total frequency. For example, exactly. 23 into 22 divided by 40. 40 is the total number, and that gives you 12.65 there. Right? Similarly, you can calculate all other expected frequencies, and then once you calculate all the expected you have to take the differences of the observed and the expected and square them up in the numerator and then add them. Yeah, you calculate O minus E whole square divided by E for the first row and for the second row, and then sum them up, and that gives you the chi-square value. And the chi-square value is come out to be 1.42, and then that chi-square value is tested against the critical value and checked.
The hypothesis accepted.
That is the formula, that classical method.
This is where I want to ask. Here the degree of freedom we take C minus 1 into R plus 1.
Yes.
Why can we take C minus 1 plus R minus 1? I can say C plus R minus 2 now. But in other one you are taking N1 plus N2 plus minus 2.
Here, logically speaking, I come to the same point that here you have categories here, three categories here, or sorry, two categories here and two categories.
That is you are
So if
taking
you fix one,
you are taking a
then
total order of the matrix.
huh?
You are taking a total order of the matrix. M into N. 2 by 2 matrix. That is M into N GC.
I think
In that form you are taking.
no. What I am saying is, what is degrees of freedom? Degrees of freedom is the degree to which it can vary, or the freedom of movement, right? Is the freedom of movement.
I do agree, but there you are taking a plus. Here you are taking a multiplications. There also you are, suppose if I arrange the data like this, expected like this one, observed like this one. That is also say N1 and N2.
But think
Then
about
that
it.
time when you are taking that is C1
No,
and
logically, if you think, sir, they are independent observations. Are they related in any way? They are not related. But here is a situation where there could be a person with a heart disease and a high cholesterol. These two variables are not independent in that sense. There is an association between these variables, right? And when probability theory, when you have independent observations, then it is multiplication. Multiplication. Something like that. I have not thought about it. Maybe give me an idea to think about it and
I
go to
will
the
think
basics.
because I am also thinking many times. Sometimes these people are writing a multiplication, sometimes they are writing a plus.
No.
What is
But it is always plus. Only in chi-square it is minus. The multiplication.
And over also.
In ANOVA also it is a multiplication.
Multiplication.
In ANOVA also it is a multiplication.
N
Yes.
minus C into R minus 1.
Yes.
N minus C into R minus 1.
R minus 1.
N minus C into R minus 1. In ANOVA.
ANOVA.
Yes.
In ANOVA you have N minus 1.
That is the first term minus C minus 1.
K minus 1 is the
Number of
between groups.
elements minus number of columns.
Columns.
Suppose you have a 3 by 4 matrix, so 12 is the element, and number of columns is 4, so 12 minus 4, 8,
And then this comes
3
4.
minus 1,
I will have to do another research. Maybe to exchange that. I don't know. We like this.
These points are creating a lot of confusion. When you are
I think any
doing
basic statistics book will give you it.
it is not given. It is given such a nice book called as an SP Gupta, SC Gupta. These people, there's an old book, these are quite old book of statistics.
Indian books never mention these.
These, not in the foreigner also say.
11 and 12 you might find.
In Menon, I have seen that. It's not there. One is book at the and he could 15 euros. Oh, what is the Lord we
We go through, and I'll ask some of my statisticians to see how to explain this, right? Okay, so we have covered this. Now we come to non-parametric tests. So non-parametric is not very useful in big situations like yours, but still we should know why they are